All right, here we are for Honors Physics, Projectiles Homework 2, Worksheet 2, and we're taking a look at problem number 4. It says, while standing at the edge of a tall cliff, a boy throws a stone horizontally with a speed of 18 meters per second. The boy sees the stone land 65 meters from the base of the vertical cliff, so that's like horizontally away, 65 meters. Determine the height from which the stone was thrown. So here we go. Here's our cliff. Right, some grass, stuff, and there's the edge of the cliff, right? Right, and we know that he's going to throw a stone horizontally off the top here. Okay, and so that starting velocity is going to look. That's my starting velocity vector. Okay, horizontally at 18 meters per second. You say, can I draw in the path, the trajectory that is going to take? You say, sure. Again, starts off horizontally. I want my pen moving horizontally here at the start. It starts to curve down immediately. Going to land out there somewhere. All right. It says he sees it land 65 meters away from the base of the cliff. So from like going to go 65 meters out. And we're supposed to figure out from that this height from which it was thrown. So we want to solve for this. All right. All right. Again, I'm going to make my table of values. I'm going to use my horizontal axis and my vertical axis. Make my chart A, V naught, V, displacement and time. A, V naught, V, vertical displacement and time. Dunk, dunk. Work, work. Dunk, 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 dunk. You say the acceleration in the x for every projectile problem is 0. The acceleration in the y for every projectile problem is negative g. That's a negative 9.8 meters per second squared near the surface of the Earth. That, of course, is assuming that I'm calling up positive and down negative directions. I'm going to label my coordinate axes there. Okay, what other values did they tell me in the problem? These are the things I can kind of start off every problem with. You say, well, they told me it starts off going at 18 meters per second horizontally. So that is my horizontal velocity is 18 meters per second. Vertically, you say, well, vertically, it starts off going just straight sideways. It starts off with no vertical speed. So I can say V naught for the vertical axis is 0. And again, that's something that I'm recognizing from the situation. They also told me this value. That's how far it went horizontally, right? That's the delta x here. The horizontal displacement is 65 meters. And they want me to solve for this. That's my vertical change in position. That's my vertical displacement. All right. And again, we anticipate that we're going to get a negative answer for that because it goes down that far. And that's what we're trying to find. Okay, so taking a look at this, you would say to yourself, well, I'm trying to find this variable. I know 1, 2, looking for a third. You say, oh, wait, I need to have 3 variables to solve for a fourth in each axis. So I'm going to need more information here. Now, do I know anything about the final speed when it gets here? It's tempting to people. Sometimes they say, oh, well, then it's going to hit the ground, it's going to stop. No. If after it hits the ground shoved on it, it's not a projectile anymore. Projectile motion is when the only force is gravity. So it's actually going really fast when it gets there. It's got some really fast vertical speed, we think. So that's not it. That's not it. We don't know that final speed. So the only other variable in the vertical axis then here is going to be time. And you say, well, I don't know the time it took for this projectile to go from here to here. But maybe I have enough information in the horizontal axis to solve for that. You say, yeah, look, I've got 1, 2, 3 solve for. Yeah, I'm going to use the horizontal axis to solve for my time, and then I can use the time to solve in the vertical axis for that missing displacement. That is the plan. So the horizontal axis, I need a formula. Well, we always use the same mathematical model for the horizontal motion. We know horizontally we're going constant velocity, and our formula for constant velocity is that the displacement is the velocity multiplied by the time. And you say, in the vertical axis, I'm going to be using acceleration, initial velocity, displacement, and time. I'm going to use those four variables. Oh, the formula that doesn't have v. The formula that doesn't have v would be delta, and I'm going to call it delta y, is v naught t plus 1/2 a t squared. So that's the plan. I'm going to use this equation to find t, and then I can substitute the time over in the y equation. So here we go. The horizontal motion. You say, hey, that displacement, we know that is 65. The horizontal velocity, we know, is 18. And so we can solve that for t. 65 over 18 is my time. If we were interested in a decimal approximation, we could get it. Oh, sure, why not? 65 divided by 18. Hey, it looks like it's going to fall for 3.61, rounding that off, seconds is the time it's going to fall for. I can take that time and substitute it into the other equation. Where I see t. In my job, I'm trying to find that delta y, so it's already arranged for me, so that's nice. So my delta y, what's my starting vertical velocity? Remember, this is the y-axis. We want to use all the vertical values. You say, well, look, it was 0. So this whole term actually just drops out because v naught in the y-axis was 0. So I'm just going to have 1/2 at squared. So my delta y is going to be 1/2 negative 9.8, because that's my acceleration, the vertical axis. And the time we just found was 3.61. So times 3.61 squared. Punching that in my calculator, you say 0.5 times negative 9.8 times 3.61 squared, and you get negative 63 point, I'm going to round that 63.9 meters. All right, that is my displacement. Now there is just one last weird comment I should make. Hey, what's the meaning of this negative sign? Well, we're describing the displacement of the stone. The stone went down. That's what that negative sign went down 63.9 meters. But technically, what they asked for is the height from which the stone is thrown. People don't usually go around saying, oh, hey, that cliff, it's negative 63.9 meters high. When people talk about the height of a cliff, they usually just report it as a positive value. So I could say for my final answer that the cliff is 63.9 meters high. And that negative sign would kind of go away there. But if I ever have to deal with the displacement of the stone, it definitely went down 63.9. So I want the negative for displacement. All right. That's it for that problem.